In this video, I'm going to discuss the problems from the exercise 5.2. Before we start discussing or solving the problems, let me give you a brief about the concepts which are required to solve the problems. So the first thing is modulus of a complex number. So modulus is nothing but it is the distance of the point z from the origin on orgone plane. So first let me tell you what is orgone plane. Orgone plane is very much similar to the coordinate plane, but in orgone plane we will have one real axis and one imaginary axis. But in the coordinate plane we'll have both real axis. So this y is imaginary axis, and here x-axis is known as real axis. So we know that every complex number has one real part and one imaginary part. So the real part of the complex number is a here, and the imaginary part of the complex number is known as b. And we know that here a and b both belongs to real numbers. A and b are real numbers. So by using this orgone plane, we'll be able to locate any complex number. Suppose if you have z equals to 2 plus i3. So now we take 2 on x-axis because 2 is the real part of z, and 3 on y-axis because 3 is the imaginary part, and this is the point of location on the orgone plane. Now the modulus is defined as it is the distance of this point from the origin. This is called r, and this is given as root of x square plus y square. It means that modulus of z is nothing but root of 2 square plus 3 square. So the same thing is applicable even though we have different combinations. Maybe it is like -2 minus i3. So this is mod z equals to -2 whole square plus -3 whole square. Right? It is the distance of this point from the origin. So where do we see -2 and -3? So this is -1, -2, and we have -1, -2, and -3 on the imaginary axis. So if we take the -2 comma -3, so this is the point of location, and when you join these two origin, we will get the modulus of complex number, and we denote it as r as well, right? So like this depends on the sign you see here. If you see that x is positive and y is negative, you will get, if the real part is positive, that means when x is positive and y is negative, you will get that value in fourth quadrant. If x is negative and y is positive, you will get it in second quadrant, the point, right? So that is the modulus of a complex number. Now let us see argument of complex number. Argument of z represented by arc g or theta is the angle that the line joining z to the origin makes with the positive direction of the real axis. Just now we have seen, right? It is the angle made by so any complex number with respect to positive x-axis. That means this is known as theta. This is known as theta. If z is any positive any complex number which has both real and imaginary parts or positive values, right? So this can be determined. What is z here? Z is nothing but x comma y here. Okay, let me write it as this as x comma y. That is, the height is y and the length is x, and we can write it as tan theta is equal to y by x. Tan theta equals to y by x, and this is our, that is nothing but modulus or mod z, right? But this argument can have infinite possible values. This is because if theta is an argument of z, then 2n plus theta, 2n pi plus theta is also a valid argument. So if you know if you go through the trigonometric functions and trigonometric ratios, you will understand that how it can have infinite values of theta. At this point, I'm not going to discuss about that. So, but in order to restrict, in order to restrict the range of theta values, we take the limits of theta from plus pi to minus pi. That means from positive axis to in anti-clockwise direction up to 180, and in the clockwise direction also up to 180, and we restrict the domain. We restrict the domain of theta, and this is known as principal argument. This is known as principal argument, where theta lies in between pi and pi. We take theta less than or equal to pi and minus pi less than theta, theta less than or equal to pi. This is principal argument. That means theta always lies in between pi and minus pi. Then how to find out this theta? Suppose if you have the theta, this complex number lies in the second quadrant or third quadrant, fourth quadrant. So what we do is first we find out the alpha, where alpha is tan inverse of mod y by x. Alpha is tan inverse of mod y by x. Here we have seen, right? Tan theta is equal to y by x. It is nothing but theta is equal to tan inverse y by x. So now we always consider the mod y by x, and now we define if the z lies in the first quadrant. If it is in the first quadrant, so with theta is just simply alpha. If it lies in the first quadrant, theta is alpha. And if it lies in the second quadrant, right? If it lies in the second quadrant, theta is pi minus alpha. And if it lies in the third quadrant, the theta is minus pi minus alpha. And if it lies in the fourth quadrant, theta is alpha. As we always get theta as positive, so these values will give us the corresponding values of argument. I mean to say that, suppose if we have a complex number, let's say that which lies in the first quadrant. So in the first quadrant, both x and y are positive, right? Both x and y are positive. So when you're trying to find out alpha, so mod y by x, this is y and this is x, right? So both y and x are positive, so that you just get theta is equal to alpha here in this case. Suppose if the complex number lies in the second quadrant, for example, let us say that there is a number, we have minus 2 plus 3i. So minus 2 plus 3i lies in the second quadrant. So there is no confusion with the first quadrant complex number, but let us see what if it is a second quadrant complex number. So that we'll go with -1, -2 here, 1, 2 and 3, right? Here also we have 1, 2, 3 and -1, -2, -3. So now -2, here the real part is -2, so that this is the -2 and the imaginary part is +3, this is the +3, so that the location of the Z is here. It is in the second quadrant, right? So in the second quadrant, so what is alpha? So we know that in the second quadrant, okay, in the second quadrant also alpha is tan inverse mod y by x. With respect to y is positive or negative, we always take this. What is this y? Y is 3 and x is -2 here. But on substituting this, you'll get plus only and we'll get alpha here. But what is the argument definition? Argument definition is that it is the angle made by positive x-axis. That is, this is theta. So that if it is the second quadrant, the theta can be determined by taking 180 minus alpha. Just we write this 180 as pi minus alpha. I hope you got it, right? Suppose instead of that, if you see that a complex number which lies in the third quadrant, if a complex number which lies in the third quadrant, let us see. For example, we have a complex number which is -2 -3i, right? So -2 -3i so let us say that this is -1, -2 and so on. So this is x and this is y and this is x dash y dash. So -3 and -1 -2. So this is the location -2 -3. So it lies in the third quadrant. So as usual, to find out the alpha, we just take the positive values of x and y. So then this would be the alpha here. But from the definition of argument, so this is the angle made by the positive x-axis, the positive real axis. So then this is our theta. But this theta is negative, that we know that, right? Theta can be determined by using as usual pi minus alpha, but this pi minus alpha gives us a positive value and we have to take it as negative, right? And the fourth quadrant, if it lies in the fourth quadrant, then it is easy to say that suppose you have something like 2 minus 3i. So -1, -2, -3 and 1, 2, 3 and so on. 1, 2, 3. This is the imaginary axis. Y-axis is imaginary. X-axis is real axis. And this is the origin. So that -+2 is the real axis coordinate. -3 is the imaginary axis coordinate. So this is the point of location of this Z. Now this will be the modulus of the given number, and now it is the angle made by the x-axis, that is alpha. I can write it as tan inverse of y by x as usual, and we get this alpha as positive values. To minimize that, to get the exact value of theta from the definition, if it is in the clockwise direction, we should have the negative value of argument, so that theta must be equal to minus alpha. So this is when it is in the fourth quadrant, right? So this is the way we have to take when we have the quadrant 1, theta equals to alpha, quadrant 2 pi minus alpha, quadrant 3 pi minus pi minus alpha, quadrant 4 theta equals to alpha, where alpha is always equal to tan inverse of mod y by x. irrespective of x and y, whether they are positive or negative, we always get alpha which lies in between 0 and 90. 0 and 90. Yes. Right? Now let us see the polar form. The polar form of a complex number is given by r into cos theta plus I sin theta, where r is modulus, theta is the argument. This is the polar form of any complex number. Okay, for example, if you have a complex number z is equal to x plus I1, where r is given as root of x square plus y square, and theta is based on that alpha, and you can find out the alpha, and once you get the alpha, from that you'll be able to find out theta, tan inverse of y by x. I hope you got it now. Now can we start solving the problems? Yes. Find the modulus and the arguments of each of the complex number in the exercises 1 to 2. So let us see that the first one, argument is easy, modulus is easy. Modulus is nothing but root of. So whenever you have something like a plus ib, okay, so modulus of it is nothing but root of a square plus b square simply. Imaginary part and the real part. What is the real part here? Minus 1 whole square. And what is the imaginary part here? Minus root 3 whole square, which is equal to root 1 plus 4 and is equal to 2. Then what about the argument? So minus 1 and minus I root 3, which quadrant they lie? So first let us find out alpha is equal to tan inverse of, right, mod b by a. Here I am taking just mod b by a because I have taken it as a plus ib, so that tan inverse of, so root 3 by 1, right? So this is nothing but tan inverse of root 3. So what is tan inverse of root 3? It is nothing but pi by 3, right? Alpha is pi by 3. Then what about theta? That depends on whether z lies in first quadrant or second quadrant or third quadrant or fourth quadrant. Now the z lies in which quadrant? Z lies in third quadrant because both are negative values. So we'll see here minus 1 and minus root 3. So that it lies in the third quadrant. If it lies in the third quadrant, what is theta? Our theta is minus pi minus alpha. Therefore, theta is minus pi by 3, which is equal to minus 2 pi by 3 is the argument of this complex number. I hope you got it. Now let's see the second question. Z equals to minus root 3 plus 1. So now let us find out the modulus. Modulus of Z is root of a square plus b square as usual minus root 3 square plus 1 square, which is equal to root of 3 plus 1 and is equal to 2. So modulus of Z is 2. Now what is alpha? Alpha is tan inverse of root 3 by 1 by root 3. So when tan inverse of 1 by root 3, what is alpha here? So it is equal to pi by 6. We know that tan 30 is 1 by root 3, right? So that is nothing but tan pi by 6 is 1 by root 3. So tan inverse 1 by root 3 is pi by 6. So now what is the theta? So for that we need to check which quadrant it is. Which quadrant complex number it is? So x is negative, y is positive, that lies in the second quadrant. When it lies in the second quadrant, we know that theta is pi minus alpha and pi minus pi by 6, which is equal to 5 pi by 6. That is the second question answer. Now let's see the third one. Convert each of the complex numbers given in exercise 3 to 8 in the polar form. So now it is easy to do this because we already know how to find out modulus and argument. So if you know the modulus and argument, the polar form is nothing but polar form is r into cos theta plus I sin theta, where r is the modulus of the number. For example, for this, r is equal to mod of 1 minus I. What is mod of 1 minus I? 1 square plus minus 1 whole square, which is equal to root 2. R is root 2. What is theta? To find out theta, let us find out alpha first. Tan inverse of minus 1 by 1. It is minus 1 or tan inverse of 1. So tan inverse of 1 is, what is tan inverse of 1? Pi by 4. Now, which quadrant it lies in? 1 minus I. So the real axis is positive and the imaginary axis is negative, so that it lies in the fourth quadrant, right? So that theta is minus alpha. In the fourth quadrant, it is minus alpha, so that the answer is minus pi by 4. Therefore, what is the polar form of this number? Therefore, the polar form of 1 minus I is r into, that is root 2 into cos theta, cos minus pi by 4 plus I sin minus pi by 4. And we know that cos minus theta is cos theta, so I can write it as cos pi by 4, and sin minus pi by 4, sin minus theta is minus sin theta, so that minus I sin pi by 4. So this is the polar form of the given number. So can I go to the next problem? So now the fourth one is minus 1 plus I. So I can take r as minus 1 plus I, so that root of minus 1 whole square plus 1 square, which is equal to root 2 again. Now what is alpha? Alpha is tan inverse of 1 by minus 1. It is again tan inverse of minus 1 or tan inverse of plus 1. When you take out of modulus, it is plus 1. So and is equal to pi by 4. Now this minus 1 plus I lies in which quadrant? So minus 1, the real part of complex number is negative, imaginary part is positive, that means it lies in the second quadrant. In the second quadrant, what is theta? Theta is pi minus alpha, so that pi minus pi by 4, which is equal to 3 pi by 4. Now the polar form of this number is polar form of minus 1 plus I is equal to root 2 into sine, first cos 3 pi by 4 plus I sin 3 pi by 4. That is the polar form of it. Right? Now let's see the fifth question. Fifth question is minus 1 minus I. See, more or less all look similar. Only the differences you can observe is the signs are changing from third to fourth, fourth to fifth problem. Now for the fifth problem also, r is minus 1 minus I mod of, so which is equal to root minus 1 whole square plus minus 1 whole square root 2. Right? R equals to root 2. And what is theta? To find out theta, first let us try to find out alpha. Alpha is minus 1 by minus 1, which is equal to plus 1. Of course, even though it is minus 1, out of the modulus it is plus 1 only, and it is again pi by 4. But which quadrant it is in? Minus and minus. So it must be in the third quadrant, right? Minus and minus must be in the third quadrant. So in the third quadrant, what is theta? We have defined it as minus pi minus alpha. That is minus pi by 4, which is equal to minus 3 pi by 4. So Argument is minus 3 pi by 4. So now we can write the polar form of this equation. Polar form is minus 1 minus I, which is equal to, what is R? R is root 2, and what is cos theta? Cos theta is cos minus 3 pi by 4 plus I sin minus 3 pi by 4. Right? We know that cos of minus theta is cos theta, so that you can write it as it is cos 3 pi by 4. And we know that sin of minus theta is minus sin theta, so that it is minus I sin 3 pi by 4. So this is the polar form of the given complex number. Now let's see the fifth one. So for the let's see the sixth one. For the sixth one, it's a complex number. So what is R? So it's a complex number of the form minus 3 plus 0 I, right? It is of the form this, so that it is minus 3 whole square plus 0 square, which is equal to 3. So the modulus is 3. So what is alpha? Alpha is tan inverse of y by x. What is y here? Y is 0 and it is minus 3 and tan inverse of 0. What is tan inverse of 0? Which is equal to 0. Right? If alpha is 0, so this theta is also equal to 0. Right? So, sorry, it is minus 3, right? Minus 3 that lies on the, between second and third quadrants, right? So when you have it on, so where do you see the minus 3? Minus 3 will see here minus 1, minus 2, minus 3. So it lies on the x-axis, right? It lies on the x-axis. So what can be done here? So that the alpha is 0 here. Alpha is 0 means, so what is the line here? What is the modulus here? This is the modulus 0 to 3. 0 to 3 is the modulus, right? So that means either we have to measure it from here or we have to measure in the clockwise direction from the positive x-axis. But how did we define this theta? Theta should always lie between minus pi less than theta less than or equal to pi, right? That means it should come from the positive x-axis in the anti-clockwise direction. It only can reach to pi. In the clockwise direction, it can go up to pi, but it does not reach to pi. So that this value must be equal to pi. Now, let us write the polar form. Now, the polar form is polar form of minus 3 is equal to, so what is R? R is 3 into cos pi minus I sin pi. Right? So this is the value. Right? This is the polar form of minus 3. Now let us see the seventh question. Seventh question is root 3 plus I. So what is our mod of root 3 plus I? So it is nothing but root 3 whole square plus 1 square, which is equal to 2. Right? Now what is alpha? Alpha is tan inverse of 1 by root 3. So tan inverse of 1 by root 3 is nothing but pi by 6. And root 3 plus I lies in the first quadrant. So the theta is equal to alpha, which is equal to pi by 6. So that argument is pi by 6. And the modulus is 2. Therefore, what is the polar form? Polar form of root 3 plus I is, polar form of root 3 plus I is equal to R into 2 into cos pi by 6 plus I sin pi by 6 is the answer. Okay, for seventh one. Now let us see the eighth one. See, eighth one we have only imaginary part of complex number. So when we have only imaginary part of complex number, how can we write this? We can write as 0 plus I. So which is equal to root of 0 square plus 1 square, which is equal to 1. Then what is alpha? Alpha is tan inverse of 1 by 0. So 1 by 0 is undefined. When 1 by 0 is undefined, what is the value of tan inverse? That is pi by 2. And this I lies in the on the y-axis, obviously, right? We have only I means, what does it mean? So that means 1, 2, if we take 1, 2, 0, minus 1 this side, minus 2. So the given one is only I, that I always lies on the y-axis, and of course it is positive I, so that it lies on the positive side. So how do you join this to origin? This is the distance from the origin. Now the argument is nothing but the angle made by this line with the positive x-axis. Therefore theta is pi by 2. Therefore theta is equal to pi by 2. Now what is the polar form? Polar form of I is equal to r is 1 cos theta cos pi by 2 plus I sin pi by 2. Right? So simply you can write it as cos pi by 2 plus I sin pi by 2. You can see here sin pi by 2 is 1, cos pi by 2 is 0, you will get I only. That is the polar form of 8th problem. Right? So that's it. I hope you have understood all the problems, the solutions of all the problems. If you like this video, share it with your friends and spread the knowledge. Thank you.